When you gaze up at the night sky, have you ever stopped to consider that each twinkling point of light tells its own unique story? Every star you see exists in a different moment of its cosmic journey. Some are cosmic infants, barely beginning to shine their first light into the universe. Others are in their stellar middle age, steadily burning through their fuel just like our own sun. And then there are those that stand on the precipice of their existence, ready to gift us with one of the most spectacular shows the universe has to offer, their grand finale. Picture this. What if you could witness an entire human lifetime condensed into just a few minutes, from the first cry of birth to the final breath? Fascinating, isn't it? Now let's take that concept and apply it to something far more magnificent, a star. Today, we're about to embark on an extraordinary journey that will take us through the complete life story of a star, from its first brilliant gleam to its dramatic end. And here's something remarkable. The destiny of these cosmic giants is more intimately connected to your very existence than you might imagine. In this video, we'll unravel the complex tale of stellar evolution, discovering how stars are born in the depths of cosmic clouds, how they live their long lives illuminating the cosmos, and how they meet their eventual fate. This isn't just a story about distant points of light. It's a story about us, about how we came to be, and about our place in this vast cosmic drama. You see, understanding the life and death of stars is crucial to understanding our own existence, as every atom in our bodies has a stellar origin story of its own. The cosmic dance we're about to witness spans billions of years, yet we'll experience it together in the next few minutes. From the stellar nurseries where new stars spark into existence, through their mature years of stable burning, to their often spectacular endings, we'll see how these cosmic engines have shaped our universe and, by extension, shaped us. Our story begins in one of the most magnificent structures in the universe, a stellar nursery known as a nebula. These vast cosmic clouds of gas and dust stretch across thousands of light years, painting breathtaking scenes across our galaxy. As Dr. Sarah Connor from the European Southern Observatory eloquently puts it, nebulae are the true maternity wards of the cosmos, where new stars are constantly being born into existence. Within these colossal clouds, primarily composed of hydrogen and helium, the most abundant elements in the universe, a delicate cosmic ballet unfolds. Picture a cloud that's unimaginably large, containing enough material to create thousands of stars like our sun. The temperature here hovers just above absolute zero, around 260 degrees Celsius, creating perfect conditions for stellar formation. The process begins when subtle disturbances, perhaps from a nearby supernova explosion or the gravitational influence of passing stars, create regions of slightly higher density within the nebula. These small irregularities trigger one of nature's most fundamental forces, gravity. Like a silent conductor orchestrating a cosmic performance, gravity begins its patient work, drawing gas and dust particles closer together. This gravitational dance is extraordinarily slow and methodical. Over millions of years, these particles spiral inward, creating what astronomers call a molecular cloud core. As more material accumulates, the core's self-gravity becomes stronger, pulling in surrounding matter with increasing force. This process, known as gravitational collapse, accelerates as the core grows denser. What makes this process particularly fascinating is its self-sustaining nature. As the material falls inward, it converts gravitational potential energy into heat. The center of this collapsing cloud gradually becomes warmer and denser, while the outer regions remain cool and continue to fall inward. This creates a structure astronomers call a protostellar nebula, the very first stage in a star's life. The beauty of this stellar nursery isn't just in its appearance, but in its efficiency. The same cloud can give birth to multiple stars simultaneously, creating stellar siblings that will eventually drift apart to illuminate different corners of our galaxy. Modern telescopes like the James Webb Space Telescope have given us unprecedented views of these stellar nurseries, revealing intricate details of this birth process that were previously hidden from our view. Inside these cosmic incubators, we're witnessing the very first chapter of stellar evolution, a process that will eventually lead to the creation of planets, complex organic molecules, and perhaps even life itself. These stellar nurseries are, in a very real sense, the foundries where the basic building blocks of our universe are forged into the stars that will shape the cosmos for billions of years to come. As our collapsing cloud continues its inexorable journey inward, we witness one of the most remarkable transformations in the universe, the birth of a star. At the heart of our protostellar nebula, something extraordinary is taking place. The temperature at the center of this collapsing mass begins to rise dramatically, reaching levels that defy imagination. We're talking about millions of degrees Celsius. This extreme heat is no accident. It's the direct result of gravitational compression. As more material falls toward the center, the pressure becomes intense and the temperature soars. When the core temperature reaches approximately 15 million degrees Celsius, something truly magical occurs: the ignition of nuclear fusion. This is the moment of truth, the actual birth of a star. Deep within its core, hydrogen atoms begin to fuse together to form helium, releasing an enormous amount of energy in the process. This is the same process that powers our own sun and every other star in the universe. It's a cosmic alchemist's dream where fundamental forces of nature transform matter into pure energy. The onset of nuclear fusion marks a crucial milestone. For the first time, our nascent star achieves a delicate balance between two competing forces: the inward pull of gravity and the outward push of radiation pressure generated by fusion reactions. This equilibrium, known as hydrostatic equilibrium, will define the star's existence for millions or billions of years to come. With fusion now fully operational, our newborn star has officially joined what astronomers call the main sequence, the stellar equivalent of adulthood. The main sequence is where stars spend the majority of their lives, steadily converting hydrogen into helium in their cores while maintaining their size and brightness with remarkable consistency. The characteristics of our new star, its mass, temperature, and brightness, are largely determined by its initial mass. More massive stars burn brighter and hotter but live shorter lives, while less massive stars burn cooler and can shine steadily for billions of years. Our own sun, for instance, has been on the main sequence for about 4.6 billion years, and is expected to remain there for another 5 billion years. This birth process, this transition from a cold cloud of gas to a brilliant fusion-powered sphere, represents one of nature's most impressive achievements. It's a testament to the incredible forces at work in our universe, where gravity, pressure, and nuclear physics come together to create the cosmic beacons that light up our night sky. If you're as awestruck as I am by this cosmic dance, why not take a moment to give this video a like? Your support helps us continue exploring these fascinating mysteries of the universe, bringing more incredible cosmic stories right to your screen. And trust me, we're just getting started. The life story of our star has many more chapters to come. The adult life of a star represents one of the most remarkable examples of equilibrium in nature. For billions of years, these cosmic titans maintain an intricate balance between two immense opposing forces: the crushing power of gravity pulling inward, and the intense radiation pressure from nuclear fusion pushing outward. This cosmic tug-of-war creates a state of perfect harmony that allows stars to shine steadily for eons. At the core of this stellar balancing act lies an incredible fusion reactor. In stars like our Sun, approximately 600 million tons of hydrogen are converted into helium every second. Despite this enormous rate of fuel consumption, the process is so efficient That a star like our Sun can maintain this stable fusion for about 10 billion years. It's a testament to the immense scale of stellar operations that such profound consumption can sustain itself for so long. During this main sequence phase, stars become cosmic factories, creating elements essential for life as we know it. Through a process called nucleosynthesis, hydrogen atoms are fused into helium, releasing enormous amounts of energy in the form of light and heat. But the story doesn't end there. In more massive stars, when core temperatures reach even higher levels, helium atoms can fuse to create heavier elements like carbon, nitrogen, and oxygen, the very building blocks of life. The stability of this adult phase is crucial for the development of life in planetary systems. Our own Earth benefits from the Sun's remarkably consistent energy output, which has varied by less than 1% over billions of years. This steadiness has allowed our planet to maintain liquid water and develop complex life forms. It's a cosmic precision that borders on the poetic. The same process that creates the elements necessary for life also provides the stable conditions needed for life to evolve. Inside a main sequence star, different layers operate like a well-orchestrated symphony. The core, where nuclear fusion occurs, reaches temperatures of about 15 million degrees Celsius. This heat gradually makes its way through the radiative zone, where energy is transferred through a process of absorption and re-emission by atoms. Finally, in the convective zone, massive currents of hot plasma carry energy to the surface, creating the familiar patterns we see as solar granulation. Perhaps most fascinating is how this steady adult phase influences the star's surroundings. Through solar winds and radiation, stars continually interact with their environment, sculpting their solar systems and enriching the interstellar medium with various elements. This interaction creates a complex ecosystem of cosmic matter and energy that will eventually contribute to the formation of future generations of stars and planets. During this phase, stars also experience various phenomena that we can observe from Earth. Solar flares, coronal mass ejections, and stellar spots are all part of the dynamic activity that occurs even during this stable period. These phenomena remind us that even in their quiet adult phase, stars are incredibly active and complex objects, constantly changing while maintaining their overall stability. Understanding this adult phase of stellar life is crucial not just for astronomy, but for our comprehension of the universe as a whole. It's during this phase that stars create the conditions necessary for planetary systems to form and evolve, potentially giving rise to new worlds and, perhaps, new forms of life. The steady burning of stars in their main sequence phase is, in many ways, the heartbeat of our galaxy, providing the energy and elements necessary for the cosmic story to continue unfolding. As we approach the most dramatic phase in a star's life, we witness nature's most spectacular show, the stellar endgame. When a star begins to exhaust its nuclear fuel, it enters a transformation so profound that it challenges our understanding of physics itself. This final chapter varies dramatically depending on the star's initial mass, leading to three distinct possible endings in this cosmic story. Let's first consider the fate of smaller stars, like our Sun. When these stars deplete their hydrogen fuel, they begin to burn helium in their cores, causing them to expand dramatically into what astronomers call red giants. During this phase, the star's outer layers swell to hundreds of times their original size, while its surface cools and takes on a distinctive reddish hue. Eventually, these outer layers are gently expelled into space, creating a breathtaking phenomenon known as a planetary nebula, a luminous shell of gas that spreads outward like a cosmic butterfly. What remains at the center is a white dwarf, an incredibly dense stellar remnant about the size of Earth, but containing the mass of a star. These white dwarfs will continue to cool and glow for billions of years, like dying embers in the cosmic fireplace. For medium-mass stars, the ending is far more violent. These stars are massive enough to fuse elements beyond helium, creating progressively heavier elements in their cores until they reach iron. Iron fusion consumes rather than releases energy, marking the beginning of the end. What follows is a Type II supernova, one of the most energetic events in the universe. The star's core collapses in mere seconds, while its outer layers are blown away in a tremendous explosion that can briefly outshine an entire galaxy. The intense pressures and temperatures during this collapse crush protons and electrons together, forming a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. These cosmic lighthouses spin rapidly, sometimes hundreds of times per second, beaming radiation into space like celestial beacons. The most massive stars in our universe meet an even more extreme fate. When these stellar giants exhaust their fuel, they undergo a supernova explosion of staggering proportions. However, the remnant core is so massive that not even the force between neutrons can withstand gravity's relentless pull. The collapse continues until it creates a black hole, a region where space and time itself are so warped that nothing, not even light, can escape. These cosmic leviathans continue to influence their surroundings through their intense gravitational fields, playing crucial roles in the evolution of galaxies. This variety in stellar endings showcases the incredible diversity of cosmic phenomena. Each type of stellar death enriches the universe in its own way, expelling different combinations of elements into space. These expelled materials become part of the great cosmic cycle, eventually incorporating into new stars, planets, and potentially even living beings. The violence and beauty of these stellar endings remind us that even in death, stars contribute to the ongoing story of cosmic evolution, seeding the universe with the building blocks necessary for the next generation of cosmic structures. Through modern telescopes and sophisticated instruments, we've been fortunate to observe many of these stellar endings in action, giving us unprecedented insights into these cosmic transformations. Each observation adds to our understanding of these profound processes that have been occurring since the universe's earliest days, continuing the endless cycle of stellar life and death that makes our existence possible. As we conclude our journey through the life cycles of stars, we arrive at perhaps the most profound realization of all. We are intimately connected to these cosmic processes in ways that are both beautiful and humbling. Every atom of iron coursing through your veins, every calcium atom strengthening your bones, every carbon atom in your cells, these were all forged in the heart of a star that lived and died long before our solar system came into existence. As Carl Sagan so eloquently expressed, we are all made of star stuff. This isn't just poetic metaphor, it's a scientific truth that connects us directly to the cosmos. The heavy elements that make life possible could only have been created through stellar nucleosynthesis and dispersed through supernovae explosions. These ancient stars, which died billions of years ago, provided the raw materials necessary for our existence. When you look at your hand, you're literally seeing the aftermath of stellar evolution. Atoms that were once part of massive stars that exploded and scattered their contents across the galaxy. The next time you gaze up at the night sky, remember that you're witnessing thousands of different stories unfolding simultaneously. Each point of light represents a star in its own unique chapter of this infinite cosmic narrative. Some of these stars are just beginning their journey, while others are approaching their spectacular finale. This tapestry of stellar lives reminds us that we are part of something far greater than ourselves, a vast, interconnected cosmic dance that has been ongoing for billions of years. Understanding stellar evolution isn't just about satisfying our scientific curiosity. It's about understanding our own origins and our place in the universe. It reminds us that despite the vast distances and timescales involved, we are not separate from the cosmos. We are an integral part of it, born from the same processes that continue to shape our galaxy and universe. If you've found yourself as amazed by this stellar journey as I am, I invite you to join our community of cosmic explorers by subscribing to the Exploring the Universe channel. Together, we'll continue our voyage through the cosmos, unraveling more mysteries of our universe in future videos. Each exploration brings us closer to understanding not just the mechanics of our universe, but our own place within it. Don't miss out on our upcoming adventures as we delve into black holes, explore distant galaxies, and investigate the fundamental forces that shape our cosmos. Hit that subscribe button, activate notifications, and become part of our growing community of space enthusiasts. Until our next cosmic encounter, keep looking up and wondering about the magnificent universe we call home. See you in our next video, where more universal mysteries await our discovery. Remember, every time you learn something new about the cosmos, you're learning something about yourself, because we are, in the most literal sense, children of the stars. Until next time, fellow cosmic explorers.